Tell me about a time you disagreed with a teammate. Introduction. This is a common behavioral interview question for software developers, backend developers, full-stack developers, senior developers, and team leads. Interviewers ask this question to understand how you handle disagreement professionally, how you communicate under pressure, how you listen to other opinions, how you use data instead of ego, how you compare technical trade-offs, how you keep collaboration positive, how you help the team make the best decision. This question is especially important for check Java developers, check backend developers, Spring Boot developers, full stack developers, junior software developers, senior software developers, team leads, agile teams. The best way to answer this question is by using the STAR method. STAR means S, situation, explain the background. T, task, explain your responsibility. A, action, explain what you personally did. R, result, explain the final outcome. A good interview answer usually spends 10% situation, 10% task, 60% action, 20% result. The most important part is the action section, because interviewers want to understand how you handled the disagreement, not just who was right. Question. Tell me about a time you disagreed with a teammate. Example 1. Disagreeing about REST API versus Kafka situation. In one backend project, a user action needed to update a downstream system. A teammate suggested calling the downstream service synchronously using a REST API. I thought Kafka would be a better fit because the downstream update did not need to block the user response. Task. I needed to explain my concern respectfully and help the team choose the best approach based on the requirement, not personal preference. Action. I first listened to my teammates' reasoning. Their point was valid. REST was simpler, faster to implement, and easier to debug. Then I explained my concern. If the downstream service was slow or unavailable, the main user-facing API would also become slow or fail. To keep the discussion objective, I suggested comparing both approaches using specific criteria. We compared, implementation effort, user response time, downstream reliability, retry requirements, audit requirements, scalability, operational complexity, failure handling. After reviewing the requirements, we confirmed that the downstream update did not need to complete immediately before responding to the user. So we agreed that Kafka was better for this use case. To address my teammates' concern about complexity, I proposed a simple event design with clear monitoring. The design included count, event ID, event type, idempotent consumer logic, retry handling, dead letter queue, audit logging, consumer lag monitoring. Result. The team chose the Kafka-based approach. The user-facing API became faster because it did not wait for the downstream system. The disagreement stayed positive because we compared trade-offs instead of arguing opinions. Why this answer works. This answer is strong because it shows check respectful disagreement, check listening first, check REST versus Kafka trade-off, check data-driven decision-making, check scalability thinking. Example 2. Disagreeing about caching situation. In one application, a frequently used API was slow. A teammate suggested adding caching immediately. I agreed caching could help, but I was concerned that we had not yet confirmed the actual bottleneck. Task. I needed to explain why we should investigate first before adding caching. Action. I told my teammate that caching might be a good solution, but we should first understand where the time was being spent. Together, we reviewed. Check. API response time, database query time, repeated database calls, data freshness requirements, request volume, cache stale data risk, front-end usage pattern. After checking the metrics, we found that the database query was inefficient and returned more data than needed. The query was doing a full table scan. I suggested optimizing the query and adding pagination first. Then, we could add caching only for low-risk reference data. My teammate agreed after we reviewed the evidence. We implemented query optimization, query index, pagination, response DTO cleanup, limited caching for stable reference data, cache hit rate monitoring. Result: the API response time improved significantly. We avoided caching unstable data too early. The final solution was better because it fixed the root cause and used caching only where it was safe. Why this answer works? This answer is good because it shows CAT, technical disagreement handled professionally. CAT, evidence-based decision-making, avoiding premature optimization, caching trade-off awareness. CAT, database performance thinking. Example 3, disagreeing about returning database entities from API situation. A teammate created a new API and returned the database entity directly in the response. The API worked, but I was concerned about long-term maintainability and accidentally exposing internal fields. Task: as a code reviewer, I needed to give feedback respectfully and help improve the API design. Action: I first acknowledged that the API was working and that the implementation was simple. Then, I explained my concern. Returning database entities directly can tightly couple the API contract to the database model. It can also accidentally expose internal fields if the entity changes later. I suggested using a response DTO. I explained the benefits. Click Stable API contract. Click Control over exposed fields. Easier front-end integration. Click Safer future database changes. Click Better documentation. Clearer validation and mapping. To make the feedback easier, I shared an existing project example where we used DTOs. I also offered to help update the mapping logic. The teammate agreed, and we updated the API response to use a DTO. Result: the API became safer and easier to maintain. The teammate understood the reason behind the change and used DTOs in future APIs. The code review stayed positive because the feedback was explained clearly and respectfully. Why this answer works? This answer is strong because it shows code review disagreement, API design knowledge, maintainability thinking, respectful feedback, mentoring, team standard improvement. Example 4, disagreeing about quick fix versus proper fix situation. During a production issue, an API was failing for a small group of users. A teammate suggested a quick workaround to bypass the failing validation. I understood the urgency, but I was concerned that bypassing validation could allow bad data into the system. Task: I needed to help the team fix the issue quickly without creating a bigger, long-term problem. Action: I first acknowledged the production urgency and the need to restore service quickly. Then I explained the risk of completely bypassing validation. Instead of rejecting the teammate's idea directly, I suggested a narrow, safe fix. We reviewed the failed requests and found that the issue happened only when one optional field was missing. So we added a targeted fix to handle that optional field correctly, instead of disabling validation. The fix included null safe handling, clear validation rule, unit test for missing optional field, unit test from normal request, regression test for existing validation, follow-up task to improve the validation module. Result: the production issue was resolved quickly. We avoided allowing invalid data into the system. The team later improved the validation logic more cleanly. Why this answer works? This answer is good because it shows balancing urgency and quality, respectful disagreement, production thinking, risk management, safe compromise. Example 5, disagreeing about monolith refactor versus new microservice situation. In one project, a large module inside a monolithic application had become difficult to maintain. A teammate suggested extracting it into a new microservice immediately. I thought that refactoring inside the monolith first would be safer. Task: I needed to explain why microservice extraction might be premature and help the team choose a practical approach. Action: I first listened to the teammates' point. They wanted better separation and independent deployment, which were valid goals. Then, I explained my concern. The module still had many shared database dependencies, unclear boundaries, and low test coverage. Extracting it immediately could create distributed system complexity without solving the root problem. I suggested comparing both options. We reviewed service boundary clarity, service boundary ownership, deployment independence, testing coverage, current coupling, team ownership, expected scalability needs, migration risk. After discussion, we agreed to refactor the module first. We improved controller service repository layering, validation separation, DTO mapping, test coverage, module boundaries, documentation. We also documented that microservice extraction could be reconsidered later when the boundaries were clearer. Result: the module became easier to maintain without introducing unnecessary distributed complexity. The team avoided a risky, premature migration. The disagreement helped us choose an incremental architecture path. Why this answer works? This answer is strong because it shows class architecture disagreement, microservice trade-off thinking, avoiding over-engineering, incremental refactoring, risk management, mature technical judgment. Example 6. Disagreeing about front-end versus back-end validation situation. In one full-stack project, we needed to validate a user form. A teammate suggested handling most validation on the front end to improve user experience. I agreed front-end validation was useful, but I disagreed with relying on it only. Task: I needed to explain why back-end validation was still necessary while keeping the front-end experience smooth. Action: I first acknowledged that front-end validation gives users quick feedback. Then I explained that front-end validation can be bypassed. If someone calls the API directly, invalid data could reach the backend. I suggested using both front-end and back-end validation. The approach was, front-end validation for immediate user feedback, back-end validation for security and data integrity, field-level error response from back-end, consistent validation rules, database constraint for critical rules, tests for invalid API requests. We agreed that the front end would validate simple fields like required values and format. The back end would enforce all critical business rules before saving data. Result: the final design gave users fast feedback while still protecting back-end data. Invalid data was blocked even if the API was called directly. The team reused this validation pattern in later forms. Why this answer works? This answer is good because it shows front-end, back-end collaboration, security thinking, data integrity, respectful technical disagreement, balanced solution. Example 7. Disagreeing during code review about test coverage situation. A teammate submitted a pull request for a feature with complex business rules. The implementation worked, but the tests covered only the happy path. I felt the feature needed more tests before merging. Task: I needed to explain the risk without making the teammate feel blocked or criticized. Action: I reviewed the code and identified the highest risk scenarios. Instead of simply saying add more tests, I listed specific cases that could break. I suggested tests for missing required field, invalid status, unauthorized user, duplicate business key, downstream service failure, exception handling, edge case input. I explained that because the feature had business impact, test coverage would help protect future changes. I also offered to pair on writing the first few tests. The teammate agreed, and we added focused unit and integration tests. Result: the pull request became stronger. QA found fewer issues. The teammate appreciated the specific feedback because it was practical and helped them improve the quality of the feature. Why this answer works? This answer is strong because it shows code review disagreement, quality mindset, constructive feedback, testing strategy, helping teammate, team improvement. Example 8. Disagreeing about deployment timing situation. In one release, a teammate wanted to deploy a change late in the day because the code was ready. I was concerned because the change affected a critical API and support coverage was limited later in the day. Task. I needed to raise the concern respectfully and help the team make a safe release decision. Action. I first acknowledged that the code was complete and the teammate wanted to keep momentum. Then, I explained my concern from a production support perspective. The change affected. Check critical API flow, database update behavior, downstream service call, customer-facing functionality. I suggested checking deployment risk before deciding. We reviewed test results, suck, rollback plan, monitoring readiness, support availability, business urgency, impact if the deployment failed. After discussion, we agreed to deploy the next morning when the team had better support coverage. To avoid delay, we prepared everything the previous day. Release notes, deployment checklist, rollback steps, smoke test plan, monitoring dashboard. Result. The deployment happened smoothly the next morning. The teammate understood the concern was about release safety, not blocking progress. The team later used a similar checklist for other critical deployments. Why this answer works. This answer is good because it shows CLAC, production judgment, CLAC, respectful disagreement, CLAC, deployment risk awareness, CLAC, support planning, CLAC, teamwork. Best short answer version. If you need a short interview answer, you can say, in one project, a teammate suggested adding caching immediately to fix a slow API. I agreed caching could help, but I was concerned that we had not confirmed the actual bottleneck yet. I suggested that we first review the metrics before deciding. Together, we checked API response time, database query time, request volume, and how often the data changed. After reviewing the data, we found that the main issue was an inefficient database query doing a full table scan and returning more data than needed. So, we agreed to optimize the query and add paging first. Then we added caching, only for low-risk reference data. As a result, the API response time improved significantly, and we avoided caching unstable data too early. The disagreement stayed positive because we focused on evidence and trade-offs instead of personal opinions. Common mistakes to avoid. 1. Making the teammate look bad. Bad answer. My teammate was wrong, and I had to correct them. Better answer. My teammate had a valid point, but I had a different concern. We compared both options and chose the best approach. 2. Sounding stubborn. Bad answer. I disagreed and pushed my idea until they accepted it. Better answer. I listened first, explained my reasoning, and used data to guide the decision. 3. Avoiding the disagreement. Bad answer. I just agreed to avoid conflict. Better answer. I respectfully raised my concern because the decision could affect reliability and maintainability. 4. No technical detail. Bad answer. We disagreed about implementation. Better answer. Mention caching versus query optimization, REST versus Kafka, DTO versus entity, frontend versus backend validation, or deployment timing. 5. No positive result. Bad answer. We eventually agreed. Better answer. The final solution improved performance, reduced risk, or helped the team establish a better pattern. Best practices for answering this question. Use the STAR method. Choose a professional disagreement. Do not blame the teammate. Show that you listened first. Explain both sides fairly. Use data, requirements, or trade-offs. Show respectful communication. Explain the final decision. End with a positive team result. What interviewers are looking for. Interviewers want to see whether you can disagree respectfully, listen to teammates, communicate clearly, avoid ego-driven decisions, compare technical trade-offs, use data and evidence, handle conflict professionally, keep team trust, focus on the best outcome. For senior roles, they also want to see technical leadership, architecture judgment, mentoring through disagreement, conflict resolution, production judgment, decision-making maturity, team alignment. Strong words to use in your answer. You can use words like listened, acknowledged, compared, clarified, discussed, evaluated, aligned, agreed, proposed, validated, compromised, focused on data, focused on trade-offs. Example: I listened to my teammates' reasoning, acknowledged the benefits of their approach, explained my concern, and suggested comparing both options using metrics and trade-offs. Good disagreement topics you can use. Depending on your experience, you can talk about REST API versus Kafka. Caching versus query optimization. Returning entity versus DTO. Quick fix versus proper fix. Monolith refactor versus microservice extraction. Front-end validation versus back-end validation. Merging PR with limited tests versus adding coverage. Deployment today versus next morning. Synchronous versus asynchronous. Processing, SQL versus NoSQL. Build custom solution versus use library. Broad refactor versus incremental change. Final summary. Tell me about a time you disagreed with a teammate is an important interview question because software development requires teamwork and decision-making. The best answer should include what the disagreement was, why both sides had valid points, your responsibility, how you listened, how you explained your concern, how you compared trade-offs, how the team decided. Good examples include REST versus Kafka, caching versus query optimization, entity versus DTO, quick fix versus proper fix, monolith versus microservice, front-end versus back-end validation, test coverage disagreement, deployment timing disagreement. The strongest answers show respect, communication, data-driven thinking, technical judgment, and team alignment.